Hello, everybody, and welcome to this session of Gimme Cloud Talks as part of the Global Azure for the Community by the Community event happening April 18th, 19th, and 20th. Gimme Cloud Talks is a proud contributor using this user group as part of the Global Azure event, which is being driven by hundreds of user groups around the world. Look on gimmecloudtalks.github.io or for the Gimme Cloud Talks Global Azure events, as well as you can go to globalazure.net to see the full schedule and all of the events that are taking place as part of Global Azure. So for this session, I want to present David Handlos, and he's going to provide a great session on prioritizing your performance tests. So let me get your screen up, David, and the floor is all yours.
Thank you, Dwayne, and I hope to live up to that one. But this is going to be a talk about prioritizing performance tests. And first thing you guys should know about me is I'm a big fan of acronyms. So it always helps. I'm kind of a big acronym person, so it helps me with my memory. So as we talk about performance tests, we'll be talking about what I call the quiet and calm approach for building, for thinking through your tests and then actually running tests. So, and then just a little bit more about myself. My name is David Handlos, as Dwayne mentioned. I have been in the field for 20-something years. I'm not going to say exactly how long. But 15 of those years have been specifically in performance engineering. That's either a good or a bad thing, depending on your definition, because it's kind of a niche. But I've been fortunate enough to spend a lot of time doing different facets of performance engineering inside of software development. And then that has come with all that time, I've gotten to do a lot of good things. I've been able to build out a dedicated performance engineering lab for a fintech firm I worked with. I was able to build basically an in-house load test tool for a company. For those of you who've used JMeter, it was basically a personal JMeter for that company. That was a lot of fun. And I've just built a complete end-to-end performance testing system that would test the company's applications every single day. It was a lot of fun. But with that, this is where I've actually learned the most, and this is some of the things I'm going to talk about. It developed a lot of learning opportunities in there. In between all that, as some of the things I've done while I've tested, accidentally disabled a credit card's user acceptance test environment while running an endurance test. And while I say a credit card processor, I mean a large credit card processor environment used by thousands of merchants. I brought down an organization's VoIP system when I was trying to test their e-commerce application, and I accidentally locked up my own dev team's Outlook because they couldn't test or get to any of their emails because I flooded their system with email alerts. So never stop learning. But first thing I guess I'll start with is why performance tests, because we have all sorts of tests already: functional tests, unit tests. Performance testing is not as actively used as other testing types, and that's for many reasons, whether you're using Azure, AWS, whatever. It might seem something that's optional because performance is not on the board. It's not on a sprint. It's rarely something that's planned in a sprint. And things don't seem like performance problems until they are. Examples in recent history: Costco's website crashing over Thanksgiving. Anyone who tried to fly Southwest in the last few years has experienced some issues. And anyone who tried to buy an I-bond a few years ago also ran into issues. All this is because of software that worked well enough at the time, but when people started to use it very heavily, the wheels really fell off the bus. So again, why? Seriously, why? Why would we take the effort to do this if this only happens once in a blue moon? because it may be more complex than other types of testing, but it gives you insights that others don't. You get to learn a lot about the system and your customers sometimes in this way. And that's why I've broken this up into two different approaches called a quiet and a calm approach. So the quiet process helps you build out the test from scratch. It's your test planning phase. And the calm approach is what you do when you're running and rerunning the tests. And I kind of came up with that just because when I first started doing performance testing, it was a very stressful time because we were having problems with problem with one of our biggest applications, and we were neither quiet nor calm. So starting from a place of quiet and calm is always helpful whenever you can. You never want to do this when you're in a rush. But the takeaways I want everyone to come away with on this is it's worth prioritizing performance testing if at all possible. And whoever you designate the performance engineer is someone who should lead this, but it's got to be a team effort. It's not just one person. Just like in many groups, sometimes it's just it's the tester guy's job, or it's the business analyst job. Now it's a team effort when it comes to performance tests, because it can't just ever be one person or it will never succeed. Again, the quiet, at the risk of repeating myself, the quiet approach helps you in the test planning, and the calm process helps in the execution. So to really put this into perspective, what is the difference with all these tests? So again, we have unit tests. A lot of us have done unit tests, validating specific pieces of code. Developers do it. You don't need much infrastructure for it. And it's pretty much either pass or fail. So my best example I could think of was if a car's tire leaks air, then it fails. Functional tests is something that testers, QA, usually do during integration testing, making sure that everything works together. And so that car can drive to Starbucks. Good, we pass. All the pieces have been assembled, and you can drive to Starbucks. A performance test adds a little more context, where you're validating not just does it work, but does it work well. So sometimes you need a lot more infrastructure for it. So in this case, we're going to keep going with the car analogy. The car gets to Starbucks, but it takes 6 hours to get to Starbucks. That's a fail in my book. So this is why performance testing is always a little bit, they're more like guidelines than what you call actual rules, because every scenario is different. Every environment's different. Every app is different. That's why this is a team effort. So let's define performance testing a little bit here. The definition is types of tests determined for speed, scalability, and if things are going to respond. So the benefits are you are confident in your system before it's released. You can troubleshoot production issues without having to release multiple builds to production. I think we've all probably been there where there's an issue, but you can't quite figure out what it is. So multiple builds are pushed to prod until you figure it out. No one wants to ever do that if they can help it. The drawbacks are it does take more resources. It takes time to set up. It takes time to build it out. And again, test results are way more complex than pass or fail. That's something that has to be agreed upon. And there's lots of different types of tests. We'll go into that in a little bit, but load, capacity, stress, there's multiple different types of performance tests, which makes things even a little more complex. So let's dig into those types just a little bit. When people think of a load or a performance test, it's literally just seeing how far a car can go on the road. I'm going to stick with this car analogy today. And for capacity and scalability, it's seeing how far and how fast the cars can go on the road while the number of cars increase. So as you continue to add cars to the racetrack, how many of them can keep going until you start bottlenecking? You can only fit so many cars on the road at a time. What is that point? But that's a little bit different than stress testing. Stress testing is seeing what happens when it breaks down. Like in this, when the bridge breaks, when the road breaks, there's just what happens. And then there's called the endurance or the soak tests, where you're just it's not that you're hitting it really hard. It's just what happens over time. So again, with the vehicle analogy, what happens to the road as you drive it over and over and over? Um, so in the technical world, what happens if you kind of have a slow memory leak, or your disk space slowly gets eaten up until you run out of disk and the system locks. So those are the kind of things you have to find out. So sticking with load and performance. This is the first type of testing. You're just trying to come up with some kind of test, trying to run the car on the road. You're trying to get some kind of baseline results for what is normal with my car, what's normal with my app, what's a good response time, what should I normally expect. And you can use this once you figure this out, you can use this for automated regression testing and test the same thing over and over. I get in the habit of testing an app almost every day if I can, over and over and over, because if the results are ever any different, then I have to figure out what's wrong. Even if the app hasn't changed, maybe something else has. So again, scalability. What happens when you increase the load? What happens if you increase the number of cars, 10 users, 20 users, 30 users? Just keep going. Basically, this is when we keep adding things until things really start to degrade. And this is where you actually have to start taking a look at, sometimes you have to start taking a look at the resources to see why it's degrading. That's where and we'll come into that later, but that's where we have to really dig into potentially why. So, and then stress. Again, this is what happens when you push things past the breaking point. It's not always possible, and you don't always want to do performance tests to break things. That's actually not the goal, believe it or not. I love to break things, but that's not the goal. When you're running a stress test, you want to find the upper limit of what something can handle, and you'll never be able to keep things from breaking, but this is when you figure out how things break. So you can at least control how it breaks instead of just getting a random HTTP 500 error or a blank screen. You can know when you should have an error message that actually means something, or telling someone who to reach out to if something happens. You can figure out how to control the problem. So again, this load tests that run for extra time, this could be hours or days. These don't get run too often just because of that, but it's still good to run occasionally. So again, database running out of disk, memory leaks, things that happen over time. So as mentioned, we're going to dig into quiet and calm. Now that we know all these different types of tests, what does this mean? Being quiet. This is the planning part. If you don't, I know a lot of people who just run and start building tests right off the bat, and sometimes that works, but I like to have a plan in place. So first things first, question, what is our goal for the testing? When will things get done? Well, when are we actually done? Or can we have a good enough? Because if you don't know what your goal is, you could be testing for infinity. And then one key part about building a performance test is what are your users? What do your tests look like? Do you even know that? And then again, this is a team effort. This should never be on just one person. So everyone involved in the project should be involved in this. So informing all the stakeholders of the types of performance tests that need to happen and how this is going to impact everyone's work. And assuming everyone is on board with this, you need to set up an environment for testing if it doesn't already exist. And this is the part sometimes you have to fight a little bit, because you might not get resources for performance testing, or you might get way less than you ask for. Sometimes I've had to bargain for some pretty substandard I've had to bargain for some less than ideal resources, but at least they'd be dedicated, so I have consistent test results. But finally, after you get through all that, then you finally can actually test. So kind of going through this again, question yourself, what types of testing? What are your expectations? What is your definition of done? When are you done with all this? And user definition. What kind of actions are you doing? Who is this user? Are there different types of users? What kind of response times are expected out of these users? This is where you really want to leverage other team members, and sometimes even business analysts might be able to help you out on this, or project managers, because maybe they have insight into what are the clients actually expect out of the application. So user definition, going back to user definition, I included this one in here just because of all the fights that I've had with actually figuring out what a user is. Sometimes it's not possible, and we have to just kind of make it as we go. But I've had 5 stages of user avoidance on multiple cases where we don't have to ask about the users. We just know. If you ever hear that, question things, because I have almost never encountered a team that just knows everything about their users. I've gotten some anger responses where we don't really know about our users, but that's not my job. So keep asking. And then, well, maybe other people might know. So again, keep asking. Some people just, at this stage, some people still try to give up, and I advise you try to keep pushing, but try to at least come up with some basic idea of what your users are, because just doing the easiest route will usually lead to, honestly, it will lead to inconsistent results, inaccurate results, and really a lot of wasted time. So I guess one example I wanted to throw here is there's user definitions. Your idea of a user is going to be different from other people's idea of a user. What we have here is a graph of what we thought in one of my previous roles. We thought that we thought that our application never supported more than 15,000 transactions in an hour. And unfortunately, we were very mistaken, because I worked in a group that supported an international customer base, but I worked from 8 p.m. to 5 p.m., 8 a.m. to 5 p.m. every day. And then I didn't realize that we had a large number of customers on the other side of the globe during 2 to 5 in the morning. So my initial tests were way off on what we needed to handle because I didn't have the full picture. So again, this is why figuring out your users is very important. So quiet, inform. The list of stakeholders can be large. Developers have to be part of this, but it's not just the developers, product owners, product managers, testers, business analysts. You need buy-off. Whoever's doing the performance testing needs buy-off from everybody to get moving forward. And the environment, is this going to be a dedicated or a shared environment? Is this just a VM that's going to get spun up that's going to be shared? Is this a VM in Azure that's shared in a shared resource group where you're not going to have a lot of consistent resource allocation? What kind of external dependencies are there? Just what do you have to work with? And I mentioned this just because I've had to do this once or twice. Performance testing on your local machine sometimes has to happen, but that is definitely the idea of definitely last resort. So again, performance testing is owned by the engineer. The engineer is the guy who's supposed to do it, but the team has to help. Whoever's designated the performance engineer can't do it all. But this is where you have to keep calm. And again, keeping calm and starting to test. Because all that was just planning. So keeping calm, this is the actual part where you test, and you have to stay calm because sometimes you have to test and retest and retest. So, but Calm is a very boring acronym, but this is I end up in this zone a lot just to make sure that everything I have is correct. So making sure everything that I have is consistent, automating as much as possible, keeping the environment as lean as possible, and collecting metrics that actually matter. Make sure you know what you're gathering and what they're for. So the consistent part, a dedicated environment if possible. If it's a shared environment, test when no one else is, if you can at all. I've encountered issues before where sometimes I don't have a dedicated system where I can run tests, and people use it from 8 to 5, or they only don't use it from 2 to 4 in the morning. So that's where automation comes in, and I've had to schedule load tests between 2 and 4 in the morning just so I can get consistent results. And find a level of load where the results are consistent. For example, a 15-minute test with 50 users, 35% of the CPU is being used, and you almost always get back, say, 0.625 seconds. If you can get consistent results, that's the main thing. Ideally, you'd want something to be completely accurate and representative of all your users, but the first key is consistency. And communicate with the team regularly about how far you've gotten. I mean, if you haven't gotten very far, if you're running into issues, tell them, because it might take a while to resolve. But regularly communicate the progress or lack thereof. And again, automating. How much can you automate? Can you schedule all the tests you have? Are they something that you can kick off through a task scheduler? Can it be executed through a CI/CD pipeline? And after the test results run, can you gather them automatically? And can you kick it off again with a pipeline? Can it be done through whenever a new version of software is built? And when the results are gathered, can you send it to the stakeholders automatically? With one of the groups I worked at, it took us a while, but we got it to the point where tests were running every day, and we just ran it every day, even if there were no new versions of software, because who knows, someone may have had to update the hardware or change something in the environment. And so we wanted to make sure our test results were always consistent. So we ran tests every morning at 5 in the morning, 5 to 6 in the morning, and every stakeholder would get an automatic email. And if something was wrong, if anything was off by even just 10%, we knew something was wrong and needed to get looked at. So lean, when I say lean, keep it lean, because external dependencies like, external API calls, MFA, anything that is not related to the app or apps you're testing can be extra noise, be extra distraction. Keep it as lean as possible. If you can, keep the network traffic separate from other environments so there's no interference. So you don't do what I did once and bring down a whole VoIP system. Keep things separate. And again, by keeping things lean, just install just what you need on the system. So as close to sure as you can that the resources are being used on the server are being used by your apps, nothing else. And one other thing I want to mention here, this is something I've seen happen way too often, is just when someone has a JMeter or load runner, or they have a load test tool, they just run it from their workstation, which is okay for just starting to test. But if you want to test over and over and over and get consistent results, you should have a dedicated machine just for the load tests in the same network as whatever you're testing. Otherwise there's latency. Sometimes there's VPN issues. They need to minimize the network traffic issues. And again, don't go too lean. I'm mentioning this just because, again, I've seen this happen way too often, where people have the load test tool and the app on the same system, exactly on the same box. And there's just too much of a chance for interference. And in my world, it's kind of like trying to have a race car in your driveway. it's really not that useful. And then the last part, this is where things can get interesting. By interesting, I mean this is part of the new. This is part of the more of a guideline thing. Gathering metrics. What do you gather? What matters? Because every app is different. Because there's client side metrics, especially if you're running things from a browser or a rich application that makes API calls. Request and response time. Um, you have to try to measure the user experience from the client side, and there's always the server side. So, what kind of metrics are you gathering there? Can you narrow down what actions are using the most resources? How can you narrow this down? What do you need to gather here? So let's. I'll start with just kind of I'll stick with basically what's kind of the big four. No matter whether this is a desktop machine, Azure, whatever. The four core ones are usually CPU, memory, disk, and network I/O. Because CPU and processor usage, one thing I've seen over and over again is people have monitors to check to see if if their CPU is going too high. If it's going 80, 90% or 100, they send an alert. That makes sense. But that's it. And so sometimes sometimes it's easy to miss the boat on, okay, if you check for the overall CPU usage, that's great, but how much are your applications actually using? Is all that CPU because of your application, or is it something else? And how many CPU cores are being used? All of them? Just one of them? Way too many times, there have been performance problems in environments where a system is only using, 25% of a 4-core server, but that's because one CPU is completely maxed and everything else is fine. It's just the application is thread locked and it's just using one core and it's completely maxed. And that brings me to my last point on that is sometimes a lack of CPU usage can be an indicator of a problem, not just when it's high. If the CPU all of a sudden is just 5% and things seem slow, there could be a bottleneck elsewhere. So sometimes the lack of resources is also a problem. And memory usage, everyone looks for high memory usage, but again, just make sure you look for how much memory usage your app is using, not just the total system usage. And sometimes high is relative. Making sure you see, like, when does it plateau? Does it just keep going? Uh, does it level off at some point? Every platform's different, but sometimes there are different quirks for a given application. One example, this is back when 32-bit applications were all the rage, but back when ASP.NET ran just in 32-bit mode, just due to the way 32-bit apps worked with IS, didn't matter how much memory you had on the system. IS could only use 800 megs. Any more than that, it would start generating out of memory errors. So, with one group I was working with, we never detected high memory usage. We had plenty of memory on the box, but we were constantly getting out of memory exceptions because the 32-bit application was trying to go over its 800 meg cap and was just generating errors. So, looking for plateaus and not just high memory usage is always good. Disk, lots of disk usage. I know I've said this with every bullet point, but always see if you can isolate how much your app is using versus the whole system. Because if your app isn't using much, but the whole system's disk is maxed, what's going on? Antivirus, what? Or if yours is doing a lot of disk reads and writes, it's very important to know because it's not as bad as network I/O, but it can still be a huge bog down on the system. And last thing, I did say network I/O. It's usually slower in comparison to disk, and I love using using APIs over the network. It's really good for pulling in extra functionality, but it also just means extra possible overhead and extra possible interference. So always keeping an eye on exactly how much extra network traffic you use is always important. So, and just a couple other things. Those are the core metrics. Just other possible things you might want to look for. Any counters or logs for response time, processing time, like IS or Apache will generate logs that just automatically tell you how much how long it took to respond. You don't have to do anything else. They're just right there for you. It's really helpful. Any counters that could let you monitor locks or queuing. They don't have it as much with some of the apps now, but there was even one point where ASP.NET had a counter called request and application queue, and if things started to bottleneck, you could actually measure how many application requests were waiting and hadn't even been serviced yet. And counters the logs from other network devices. Remember, it's good to keep it as lean as possible, but still sometimes there might be some extra devices in there, a firewall, a router. Don't forget to keep those into account. I've run into more than one case where everything was fine. The apps were fine. The servers are fine. The network routers were a problem or misconfigured. Make sure everything is being taken into account in the whole environment. So just to recap, I'm kind of going through a lot, but we have a quiet process for question why you're testing, define your users, inform everyone what you're planning, set up an environment, and then start to test. Once you do start testing, test until you get things consistent, automate everything that you can, keep it as lean as you can. And if you are gathering things, make sure that they're meaningful for you. Make sure that you can actually learn something from the metrics you're gathering. All right, so what now? Because I've thrown a bunch of stuff, thrown a bunch of acronyms and a bunch of different definitions at you. I just want everyone to take away that performance testing is useful, but obviously it takes a lot of effort. It's very useful, but there's a lot to it. It's a lot more than just a unit test. You might actually get pushback from team members because everyone wants a pass or fail answer. I like a pass or fail answer, but it's not always a possibility. When you're starting from scratch, use the quiet criteria, even though it's corny, to try to get moving so you can at least define your progress, define what you want to do. Once you're starting to test, keep calm and repeat. Focus on repeatable load tests that can be used for regression and just keep building. And this is usually where I ask for any questions. This is a recorded one, so there aren't going to be any questions except possibly Dwayne. But
no, it was a very informative presentation, and like how you brought in some of the gotchas and lessons learned that you've had over the years as well. So those are very helpful.
It's just basically I'm about 15 years worth of what not to do, I think, at this point.
Well, when you're working on performances on networks, that generally is the case, right? You definitely a lot of trial and error and a lot of, there's best practices out there, but when you get into your own network environment and all of those and application environment, it does those can sometimes just have to be thrown out the window. So
sometimes outside of two windows, yes.
Yeah, sometimes, a big bay window or something like that.
Yeah.
Or door.
Yes, totally.
All right. Well, thank you very much, David. I appreciate you taking the time to get this Global Azure session recorded, and I hope everybody enjoys it. You can certainly leave comments in the YouTube, with the video, or probably, I'm sure David can find you on social media and ask any questions if necessary. If anybody wants to pick your brain on anything afterwards, so. certainly appreciate your time, and I appreciate anybody that's taken the time to watch this and any of the other sessions. Again, Global Azure is going on April 18th, 19th, and 20th of 2024 this year. And I want to thank all the organizers that are involved in this. I've talked to a few of them during this process and getting the Gimme Cloud Talks on the GitHub repo onto their repo so that we pin to the Global Azure. I've also conversations. My company, Captain Hyperscaler, is a proud sponsor of this event as well. So we're doing a lot to help the community and to help the community learn over the course of these 3 days on a global scale, which is really fun. I think this is about the 4th or 5th year I've been involved in Global Azure in one way or another, whether it was just a presenter or I've actually helped to organize some sessions, I think the last 3 years. So again, thank you, David. Appreciate your time and appreciate your presentation. Yeah. And until next time, thanks everybody.
Thanks.